So, differentiable graphs. The easiest way to define if something is a differentiable graph is to actually show all the cases where it is not. So these are all where they are not differentiable. Okay. Now these graphs are differentiable in places. So sometimes if they ask you if a whole graph is differentiable, you'd look and say none of these are. But you can have portions of the graph that are actually differentiable, correct? So this graph is not differentiable here because whenever you get a cusp or a corner, you can't find, you can't do the derivative of it because it would end up with a what type of tangent slope? Vertical, and vertical is 1 over 0, right? Vertical slopes are undefined, so that's why you can't, right? So this one's out the cusp corner, okay? The next one is out because it's discontinuous. So this is the part that kills the differentiability of this. Now, is the graph differentiable everywhere else? Yes. But there, on that graph, it is not. Same thing with this one. It's differentiable on both sides of that cusp corner, but it's not at the actual cusp corner. And then this one, when you get a vertical tangent, you get that straight up and down tangent, this is where that differentiability dies.
Wouldn't that not be a function then?
It actually wouldn't be. Okay. Because for every x, there's not one y. That would be, that x would have more than one y. Okay. The key thing to understanding Rolle's theorem is understanding what the heck we're finding. Okay? So let's go through here. There are things that have to happen in order for Rolle's theorem to be able to happen. So like, remember when we did the intermediate value theorem? It was we found a value of y below, we found a value of y above the x-axis, and if there was a value of y below and a value of y above, and the graph was continuous, then we could say there was an x-intercept, correct? Intermediate value theorem. So intermediate value theorem states that wherever your y is on one point, wherever your y is on the other point, and the graph is continuous, there exists y's that fall between those y's, right? But we have to state continuity, remember? And on the test, if you guys didn't write, if you didn't state that the graph is continuous, I took off marks because then you would not be proving the intermediate value theorem. Same thing here. Rolle's theorem has three things happening here. So it has, the graph has to be continuous from A to B. Does it say the graph has to be continuous everywhere? No. So could you do Rolle's theorem for pieces of a graph?
Yes.
Yes. So it has to be continuous in that closed interval. Okay? It also has to be differentiable in the open interval, so between A and B. We don't look at the endpoint because differentiability will die on an endpoint, right? It could be vertical. And then, for Rolle's theorem, you have to have an f of A that equals f of B. Okay? So you have to have two pieces on the graph that end up having the same y value. What are the easiest places to look for same y value? X-intercept. So that's what we often look for. And we find it if there's more than one x-intercept. Now, guys, if there's more than one y value that are the same, so this is not a genius concept. If this y value is the same as this y value, and the graph is continuous, right? Does there exist somewhere that there probably is a max or a min? Because it's going to have to do this, or it has to do this, right? You're going to be given the equation, so you'll know that it is not a horizontal line, a constant, correct? So if I find two y values that are the same, then using Rolle's theorem, there exists some sort of max or min that's happening here, because it's going to have to curve and come back up, or curve and go back up. Yep.
It's a constant term like 10, and it's just like a line.
Yeah, but they would have to give that equation. And they give us the equation, and the equation isn't a constant. Yeah, right? That's why you have to state all these concepts before. That's why you have to say that f is continuous, because it's a polynomial. It's continuous on the interval between a and b. It's differentiable because it's a polynomial, so it's differentiable between a and b. And then you can have to find two y values that are the same, and then you can use Rolle's theorem. So you have to get those things first.
Okay.
Okay, so let's look here. Find the x-intercepts. Why am I finding the x-intercepts? To get two equal y values. Could I have put in y equals 1, 2, 3 and try and find those x values, or 0, -1, -2, -3, -4? Yes. But with Rolle's theorem, I'll always look for the x-intercepts first because they're the easiest to find. Okay? Because ultimately I need two y values that are the same in order to use Rolle's theorem. to say that it has to come back up or come back down. Okay, so I'm going to find the x-intercept. So I'm going to say f of x equals x squared minus 5x plus 6. Then I have 0 equals x minus 2, x minus 3. And then x equals 2 and x equals 3. So I need to have an f of a equals f of b, correct? So I'm going to have f of 2 equals f of 3 equals 0. Prove that they are the same value. Do we agree? Yes. Yeah. So we can't say now because of that there exists an interval, an f prime of c that's equal to 0. So here it says, show that find the x-intercept, show that f prime of x equals 0 for some value c belonging to the interval by the two x-intercepts, and then find c. So first off, we have to show that there is two f values that are the same. We could have showed that second. Then we have to talk about continuity and differentiability, correct? Now, this is a what type of graph equation? Polynomial. So since f of x is a polynomial, it is continuous from 2 to 3. You agree?
You forgot a comma after polynomial.
Since f of x is a polynomial, breathe, it is continuous from 2 to 3 and differentiable from open dot 2 to 3. So we say the three conditions of Rolle's theorem are satisfied. Yep. So do you with intermediate value theorem, so do you with mean value theorem, because you have things that you have to satisfy. Since conditions of Rolle's theorem are satisfied, this guarantees that there is a number c
That's not like an independent clause.
You guys are killing me. That there is a number c, and yes, there can be a number c in the open interval well, you better 2, 3 for which
That's a crazy one.
period in here.
Will it be okay if you like paraphrase?
What?
It'll be fine if you don't say word for word and just say that it's satisfied.
Rolle's theorem satisfied guarantees C exists in interval.
No.
Could you say Rolle's
For
theorem
which
satisfied?
f prime of c equals 0.
Could you say like on a test saying writing so much like Rolle's theorem is satisfied to mean that a function is following to be continuously differentiable and therefore a number c exists in interval.
You think that's shorter? You're just literally resaid what I said. Just
It's less writing because it's less big.
no, it's not. You just literally put this in the middle of whatever you just stated. You just went this, put that in the middle, then wrote that.
It's less big words.
No, it's not. You said exactly what I said and put the sentence in the middle of those two.
What? F prime is C0.
Okay. Now, why would there be a place where f prime of c equals 0? When does f prime of c equal 0? Yeah.
Okay.
Okay, but why?
because the zeros of a derivative of number are the maximum or the maximums, the extremums.
So when y equals 0 on the first derivative, that's where you have a horizontal tangent, which is where the max and mins exist. Yes? So we just said that if there are two y values that are the same, correct? We just said this in layman's terms, not in the crazy mathematical terms. If there are two y values that are the same and this graph is continuous between those two y values, at some point there's going to be a min or a max. We said that, right?
Yes.
So in mathematical terms, what we say is there's a polynomial, which means it's continuous, which means I can actually do the derivative of it, which I have to be able to do the derivative of it because I'm finding a place where the first derivative is equal to 0. If I can't do the derivative of it, this gets kicked out, right? So because it's a polynomial, this graph is continuous between 2 and 3, and it's differentiable between 2 and 3, so I can find the first derivative of it, and I have two y values that are the same. At some point, it's going to have to curve back and give me a horizontal tangent. Correct? A max or a min. So that's what Rolle's theorem is stating. Rolle's theorem proves that between two y values that are the same, you're going to end up with a max or a min, which is you're going to end up with a place where f prime of x equals 0. Correct? Because it's going to curve back. That's what Rolle's theorem is stating. So then it asks us to find c. So how do we find c? Well, we have f prime of c equals 0. We want to find c. Can we not find f prime of c? What is f prime of x? 2x minus 5, correct? So what's f prime of c? 2c minus 5 equals 0. We agree? Literally just finding the first derivative and putting c in it. Then I'm solving for it. So I'm going to get 2c equals 5 and c equals 5 over 2. What is this value?
Doesn't matter.
It's a max or a min. That's all it is. It's the x value, the critical number where the max and min exist. So Rolle's theorem is proving that there are maxes and mins. That's the key thing to Rolle's theorem. This thing here is proving that there are maxes and mins. That's what you use Rolle's theorem for.
So why do we have to do all the yapping? Why can't we just like sub in find the first derivative and then?
Because you're not proving anything if you just find a first derivative.
Didn't you already tell us that means max and min?
Yeah, but you have to prove that the graph is actually continuous and differentiable in order to find that value. And Rolle's theorem proves that there's a value. Rolle's theorem doesn't mean that you have to find c. Rolle's theorem is just stating that there is a c that works. Welcome to theorems and welcome to mathematics and university. Yeah. X. Oh, because it's in here. Right? Okay. That's Rolle's theorem. I have my book open. So I'm going to have you work on one question to work on it. And it is page 309, number 9.
I'm not going to read my paper. I'm just going to write a whole paragraph.
You get a whole 3 minutes. Then we're moving on to... Okay, mean value theorem. So Rolle's theorem, you get two y values, prove that it's continuous, prove that it's differentiable, and then you can say there's a min or a max that falls between those two x's, where the y values are the same, because it's connected, correct? That's what Rolle's theorem is for. Mean value theorem, let f be a function defined on a closed interval a, b. If f is continuous from a, b, and differentiable, so still the same thing you need. You need continuous and differentiable in order to use mean value theorem. You need continuous and differentiable to do Rolle's theorem. Bless you, guten Tag. Now, what this is showing is then there is at least one number c, at least one number c on the open interval, where f prime of c equals this. What is this?
No, that's the average. That's a slope.
This is grade 10 slope. Quiet, please. That is grade 10 slope. So the mean value theorem states that if the graph is a continuous function and it's differentiable, and I have two endpoints, correct? And I find the slope of those two endpoints there will exist a tangent slope somewhere on the graph between those two endpoints that is the same answer. So an example might be, if I use this, oh boy. So here's an endpoint, here's an endpoint. Everyone paying attention, because I will lose you. I see people not paying attention. Okay, you see two endpoints? The right-hand side is literally just grade 10 slope, correct? So if I find grade 10 slope between those two endpoints, so here to here, do we agree? There will exist a tangent slope somewhere on an x value along that path that will have that exact same slope. So if I drew that up here, it might be here. Right? Maybe here. Do you see how that is the same slope? And maybe, oh gosh, this is me eyeballing it, maybe here with the same slope. Pretend those are actually parallel. Do you see what I'm saying though? These are tangent slopes, correct? This is tangent slope, is it not? So if I find the slope between the two, the grade 10 slope between those 2 points, I can then try and look for the C, or the x value, or values, this one would have had 2, where that tangent slope is equal to the actual slope between the two lines. Do you get what I'm saying? So mean value theorem is to show that there's actually a tangent slope equal to the slope of the two endpoints. So Rolle's theorem is to prove there's a maximum in between two of the exact same y values. Yes? Continuous function, a continuous function, that there's a min and a max between those. Mean value theorem, mean is the average, correct? Mean is the same word as average, not mean. Xavier asked me if this is going to be a very mean, like not very nice formula because it's a mean value theorem. Get it? I liked it. I'm going to use it for years to come.
Remember, you guys have a student-teacher relationship.
Yeah, still think it's hilarious. Still going to use it for years to come. I'm going to pretend it was mine. Okay?
Like all great things.
Yeah, so when actually, I'm going to first play it off as it's mine, and then I'll give you credit.
And name drop, right?
Yeah.
Okay.
The other calc class hasn't got there yet, so when I do, I'm going to play it out, see how it goes. Test the waters with it. Yeah, if not, no name drop. It was all me. Okay, I can do that. All right. So, does that make sense? F prime of C, there exists some horizontal tangent that is the same, or sorry, not some horizontal tangent. Some tangent slope that's the same as the slope between the two endpoints. Okay, so let's go here. It says verify the function f of x equals x cubed minus 3x plus 5 satisfies the conditions. There are two conditions in order for it to be mean value theorem to work. It has to be what? Continuous, and it has to be differentiable. So it has to be continuous between the closed interval, and it has to be differentiable between the open interval. And what are the values we're using? These two, because they gave us the value. Okay? So, we have to verify. So we have to say, since the function is a polynomial, quit your whining. I really badly don't want to put a comma now, because you have to tap me on it. It's a polynomial. The function is continuous. Okay. Continuous from closed interval, -1 to 1. Oops, that's closed. And differentiable. Therefore, the mean value theorem is satisfied. Oh my gosh.
Did Job's sister complain this much?
Nope.
She's also a nerd. Yeah. Yvonne Henning, you're a nerd.
No. Smartest person ever. Also super sweet. Very friendly. Great human.
So everybody in this class is dumber than her.
Nope. Just said that she is great. Amazing. Funny. Kind.
So she is.
She is. Well, that's what you do.
Am I just?
All right. Okay, so we have to find the number or numbers C that guarantees the mean value theorem. So you need to memorize the mean value theorem. It's not hard. It is f prime of C equals grade 10 slope. So you could do f of A minus f of B. You could do f of B minus f of A. It doesn't really matter. Whatever you pick, you have to put the bottom the same. Correct? Second, you go f of B minus f of A. Some people get stuck on the formula, B minus A. Don't get stuck on the formula. It doesn't really matter, right? It just matters that you actually fill that in. So we're going to need the coordinates, correct?
Yes.
We have -1 and something, and 1 and something. We need to get to what those somethings are. How do we get them? By plugging it back in to the original. So I'm going to find f of -1. When I plug it in, I get 7.
Oh. So you're just not going to do that.
F of 1, we get 3. I'm pert near done, okay? Pert near.
Is that valid? Something we do on our exam?
You can do that and you'll be fine.
Okay.
All right. So on this side, we just need to pick whichever, guys, whichever coordinate you're going to go through first. So I'm going to do the second one first and then the first one second. So I don't know why that's what I'm doing. So I'm going to go 3 minus 7 over, and then I have to follow the same suit of my x's. 1, bless you, minus a minus 1. So on this side, I'm getting -4 over 2, which is -2. Do you agree? Okay, the right side is f prime of c. So I need to get f prime of x and just put in c's. That's all that is, right? So f prime of x is 3x squared minus 3. And if you're like, where did I get that from? The equation. Nah.
Where did you get the 7 and 3 from this lab?
Plugging it into the original.
Oh, you just need to do the math. Never mind.
Because f of -1 means plug it into the original.
You just skipped the math, so I
So
was
how
just
do we
thinking-
know he couldn't use a calculator?
F prime of c equals 3c squared minus 3. I don't get paid enough some days. Today is one of those. Actually, I think it's every day. So we're going to put that on the left. 3c squared minus 3. Okay, guys, literally, I just found f prime and put a c in it. That's all I did.
Yeah.
And then guess what? I filled it into f prime of c because it's that is what it is.
You're going to pay me back.
The marker would tell that
Mind
you
blown.
did.
All right. So then I have to solve it out. So I'm going to get 3c squared minus 3 equals -2. 3c squared equals 1. C squared equals 1/3. And then I'm physically taking the square root with my arm. What do I need to remember to do? Plus or minus. And then in grade 10, remember, they taught you that you could split the radical up. And the only reason why you would split the radical up is if one was a perfect square. Correct? So you could go plus or minus root 1 over root 3, which results in plus or minus 1 over root 3, which you could keep it like that, or you could rationalize it to root 3 over 3. You do whatever you need to match on a written response, totally acceptable. So what is that saying? That's saying there is a slope of -2 between those two coordinates, correct? There's a slope of -2 between those two coordinates. Do you agree? When x or c equals 1 over root 3 and -1 over root 3, at that place, we're going to get a tangent slope of -2.
Wow.
Right? And we could double check it. We could plug that into f prime. the 1 over root 3 and the negative 1 over root 3, and you get a slope of negative 2 because you just solved that. So that's what the mean value theorem is. Now, where could it be used in a word problem? Well, let's look here. Use the mean value theorem to show that a cart that travels 110 miles in 2 hours must have a speed of 55 miles per hour at least once. So what we need to do is we need to find the slope of the beginning point and end point. So the end point is 2 hours and 110 miles. What was the beginning point? We need 2 coordinates. 0 hours and 0 miles. This one always cracks me up. People can't come up with it. So we're going to do, oh my gosh, average velocity. The peanut gallery is loud today. Average velocity. So what do we do when we find the average of something? Whenever it says average, grade 10 slope, correct? Instantaneous velocity is first derivative. Average velocity, grade 10 slope. So we're going to do 110 miles minus 0 miles over 2 hours minus 0 hours, which equals 55 miles per hour. So if we ever want to use, so we took these 2 endpoints and we found at some point there's an average velocity of 55 miles per hour, which is what they're asking me, correct? So we can say obviously now there's an average velocity of 55 miles per hour. Or if we're using the mean value theorem, what do we have to state? Since the function is a polynomial,
Yeah, how do you know it's a polynomial?
how do you know it's a polynomial? Because in order to get velocity, it has to be
No relative
go up and come back down.
So,
Like you don't just do this.
what if it's a linear?
That's still a polynomial.
Another question.
Drives and then stops, so then you have a straight line.
Straight line's differentiable. Vertical line's not differentiable. Straight line's totally differentiable. In order for it to stop, no, you'd end up having a gap. This thing is, you're going to say since it's a polynomial, it's just the car is traveling. It's not saying that it's stopping anywhere. Okay.
Well, wait, what happens if the car was already moving before you started recording the time? It started like...
It didn't say that. You're doing some serious assumptions. Okay. Since a polynomial, it is continuous. From,
Since it's polynomial, it is continuous.
yeah, don't really care. And differentiable. From 0 to 2. There exists at least one time where f prime of c equals 55 miles per hour. So page 309, 25, and 57. So when do you have to use L'Hopital's rule? When you check that, so here it says steps for finding a limit using L'Hopital's rule. So you check that f over g is an indeterminate form. So that means when you try and plug in the limit, you get 0 over 0 or infinity over infinity. If it is not, do not use L'Hopital's rule. Differentiate f and g separately. So you differentiate the top, put f prime, differentiate the bottom, put g prime. Then that is equal to the limit as just basic. And then you provide the limit of the number. F prime over g prime is an indeterminate form at c. So you plug it into the derivative and it doesn't work, then you just do it again. Okay, sounds way more intense than it is. So if I plug in 0 right now, tan of 0 over 6 times 0 is 0 over 0. It's an indeterminate form. Okay? So I have to use L'Hopital's rule. So what you do is you write out the limit as x approaches 0. That doesn't change. But you take the derivative of the top. We don't have to do quotient rule, which is fantastic. You do the derivative of tan x. What's the derivative of tan x? Secant squared x. And what's the derivative of 6x? 6. So I know the bottom no longer is 0. Correct? So I can actually plug right in. If the bottom was still 0 and the top resulted in a 0, I would just do it again. I would do the limit as x approaches 0, do the derivative of secant squared, do the derivative of 6, and go until I don't get an indeterminate form. Sorry?
End up just keeping zeros in.
It will cut off if you have any polynomial on any side, because a polynomial will eventually just turn to a number. Yeah. So secant squared x, now we can plug in. So we get secant squared of 0 over 6. Secant is the same as cos, right? Just flipped. So what is cos at 0? 1. So what is 1 flipped? 1. What's 1 squared? 1. Cool. So we have 1 over 6 and we're done.
Oh, no.
Yeah.
If you had to keep dividing it to get like a number not 0 on the denominator, would you have to state like something?
Nope. You just keep going. Yeah. All right. Shh. We're going to try this one. So when I plug 0 in, I get 0 squared on the bottom, and sine of 0 is 0, 0 minus 0 is 0, 0 over 0. It's indeterminate. I have to do L'Hopital. So I do limit as x approaches 0. What's the derivative of sine x? Cos x. And then what's the derivative of negative x? Minus 1 over 2x. So I have to do it again because currently I have a problem. Okay, so now I get the limit as x goes to 0. What's the derivative of cos x? Negative sine x. What about minus 1? What about 2x? 2. Now am I good to plug in? Yeah. So now I'm going to get negative sine times 0, and not times 0, negative sine of 0, and 2. What is sine at 0? 0 over 2 is? 0. We're done. Right? This one. The limit as x approaches infinity. So when it approaches infinity, you can do the derivative of the top and do the derivative of the bottom, and we're going to use some knowledge that we have. So I'm going to go the limit as x approaches infinity, because currently I don't know what this one would be. Shh. Could I plug in 100, 1,000, whatever, and look at the table and see what it's approaching? Absolutely could. Non-calculator section. Oh crap, right? So there's got to be a way we can do it to not have that happen. What's the derivative of ln of x? 1 over x. What's the derivative of x? 1. So this is technically just the limit as x approaches infinity of 1 over x. Now we used this when we did vertical asymptotes. Remember when we did vertical asymptotes, we divided by the largest x? And then anything that was a number over x or a number over x squared or a number over x cubed as I approached infinity would result in a what? A 0. Now why is that? If I plug 100 in here, I'm going to get 1 over 100. That's 0 decimal 0, 1. And then 1,000, million, 0 decimal 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, which is 0. All right.
So to get the answer, you have to divide by 0.
No. Good gosh, no. We use our knowledge. We don't. You're dividing by infinity, which you can't do. You have to just know that 1 over x is as you approach infinity. Yeah? Guys, please stop.
Or 1 over x. So after the one is ln x over x, it was ln x over 2x. You had to do this.
Then you would result in the 2 and you'd have to use a different rule. Yeah.
What?
Okay. Remember, they're not going to go out of the realm of the limits that you know, right? Because you're going to have other knowledge as you go along. There's calculus doesn't stop at Calc 1. It goes to Calc 2, Calc 3, Calc 4. There's actually 4 of them in university. So we're just starting our calculus journey. There's going to be way more. And when we do integrals, we're doing very minimal amounts of what we can actually anti-differentiate or do the integral of. There's way more that you can do. We're just touching. Okay. So this one, we get the limit as x approaches infinity of 1 over e to the x. Now remember, e is like 2.718 blah, 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 blah. If I raise that to 100, or I raise that to 1,000, or I raise that to 1,000,000, I'm just getting a big number on the bottom in the denominator, correct?
Yeah.
When I do 1 divided by a big number, what do I get?
Smaller number.
You're getting a smaller number. You're getting closer and closer to what? 0. This also equals 0. Now flip over. This one's a big kahuna. Shouldn't have an F, just do this. My computer thought it'd be nice and auto-correct me as putting an F. Okay. This one has a product rule in the bottom, correct? Think maybe there's a better way. So what we're actually going to do is we are going to do almost like a trig proof to knock this down to a better method first. We're going to replace stuff. So we're not actually doing the limit first. We're not doing L'Hopital's rule first. We're knocking this down by doing mathematical exchanges. So tan x, what could I rewrite that as? Sin x over cos x. Minus sin x. To put these together, what am I going to have to do? Common denominator of cos x. So this is currently over 1. I'm going to have to multiply it by cos x over cos x. Okay, then the bottom I have x squared over 1, and it's being multiplied by, what can I change that to? Sin x over cos x. All right. Oops. I don't even know what I just did. Where'd it go? Okay. So we have the limit as x approaches 0 of sin x minus sin x cos x all over cos x divided by x squared sin x over cos x. Fun fact, we can cross these cos x's off. Why?
Because you're making a sandwich, you can just get rid of this.
You're making a sandwich and you can get rid of the...
Yeah, that's how you do it.
Yeah. Yeah.
That's how I do it every time.
Yeah. Or it's because you end up actually inverting and multiplying what you're dividing by and they cancel. So that's why. But you can just do that. Now I told you when you get stuck, what often is it when you get stuck? GCF or difference of squares, correct? What's the top? A GCF. So we can take a sin x out. When we take out a sin x divided by sin x is not just gone. It's a 1 minus cos x over x squared sin x. Then what can I do? Sin x's. And you should not be annoyed right now. You should be just happy that I'm not asking you for non-permissible values. Okay? Take that.
Thank you.
Yeah, you're welcome. So now I have the limit as x approaches 0 of 1 minus cos x over x squared, which is a lot easier to deal with than a product rule in the denominator. Correct?
Yep.
So now are we in a form we could do L'Hopital? Yep. So we're going to get the limit as x approaches 0. What happens to the 1? Goes away. What happens to negative cos x? Becomes positive sin x. And then 2x in the denominator. Can I plug a 0 in currently? Nope, still an indeterminate form. So what do I have to do? Do it again. The limit as x approaches 0. What's the derivative of sin x? Cos x. And the derivative of 2x? 2. And now I can plug in. The limit goes away when I distribute in. Okay, so page 338, don't know why I have an extra comma. 39, 35, they're out of order, I don't care. And then page 340, AP number 2 and 5.